afternoon, ladies and gentlemen. My name is Dan Colborne, and I'm Projects and Specifications Manager for Nexans in the UK. Thank you very much for spending this lunchtime with us on this lovely sunny Friday afternoon. I'm here to deliver Nexans CPD certified module on fire safety, focusing on low fire hazard cables. Nexans, as you may be aware, is a world-leading cable manufacturer. We're involved in multiple industries, one of which is low voltage cables for building applications. This also obviously includes cables that would be designated as low fire hazard. So the objectives for today's course is we're basically going to take a look at a comparison between what we would refer to as a standard cable. Just to give you some background, that's a cable that we would designate as not being designed to be a low fire hazard, versus cables that are actually designed to be low fire hazard. We'll take a closer look at how low fire hazard cables contribute to fire safety. We'll compare those with standard cables, and then we'll take a look at some leading standards. We'll pick out a few to run through with you. So the agenda for today, it looks quite a lot, but it flows quite nicely. As I said, to start off with, we'll take a look at a standard cable and how that reacts to fire. You could probably see there the material that we're going to focus on. Then we'll lead on to low fire hazard cables. And just to say now that when I'm referring to low fire hazard cables, I'm referring to more than one type of cable. I'll clarify a couple of different types a bit later on in the training and to their applications. And then we'll look at some examples where low fire hazard cables are actually insisted upon, not requested. And then at the end, we'll have some time for some questions and answers. I am joined today by my colleague, Gerhard Novak. You can't currently see him on screen, but Gerhard will be monitoring any questions that come in, and he'll join me at the end, and then we'll run through some answers with you. This course also includes a quite handy little Jargon Buster, which I'll touch on at the end, but this course will be made available to you to download upon its conclusion, and obviously the Jargon Buster is there for you to refer to. So the course follows a quite simple question and answer format. As I say, it's as this is a webinar, we will kind of run through the questions and answers and then have additional questions at the end. But as I said during the agenda, what we're going to do first is have a look at what we refer to as a standard cable, or as I said, a cable that has no resistance to fire. And the material we're going to look at is PVC. So just to give you a bit of background before I answer this question, nice easy question to start with. It's important that we still talk about PVC. As you may be aware, PVC probably in the top 5 most used plastics in the world. Heavy use in industry, and of course used in a lot of applications in the past for commercial buildings, and also obviously including cable. Material that was, if you look at the history of PVC, was actually almost discovered by accident a couple of times back in the 18th century, sorry, the 19th century, but it was really the 20th century where we saw it being widely used in industry. So that's why it's important that we talk about PVC as a standard material for the manufacturing of cable. So now I've given you some background, we can kick off with a nice easy question to start with. What does PVC stand for? And obviously, as I'm sure that most of us are aware, it's obviously stands for polyvinyl chloride. But now it's important to have a look at the history of PVC and its relation to building. So probably a relevant question to ask is, why were PVC cables historically used for applications in building construction, especially cables? And really, just to give you some background or a clue to the answer to this question, it was an event towards the middle of the 20th century, involved a lot of nations, required a lot of manufacturing of equipment and materials, which obviously led to PVC being more widely used in construction. And for those of you that haven't guessed, the event was the Second World War. So PVC became more widely used at this time as an alternative to rubber. It was deemed more cost effective, but also it had some plus points. As you can see, their durability, flexibility, and ease of use, but also some flame retardancy. We'll clarify a bit more of that in just a little while. So as I said at the last slide, PVC has some flame retardancy. However, there are some issues when it is exposed to fire. So now we're going to explore those issues now. So I'll ask the next question. What are the issues with PVC cables with regards to their reaction to fire? Oh, there are two main issues. The first that we need to talk about is when PVC burns, it produces toxic hydrogen gas, which, as you can see from the slide, can be very toxic for humans. Obviously, it can irritate skin, eyes, cause breathing problems. So that obviously is not great for someone that is in trying to evacuate a building on fire. The next main issue with PVC is that when it burns, it produces thick black smoke. So if you can imagine, if you're in a fire, a PVC fire, and trying to escape from the building, not only is your body under attack from the toxic gases that are produced by PVC, but also the thick black smoke is making it very difficult to navigate your way out the building, and obviously is interfering with vision. So two key issues for PVC material when exposed to fire. So now that we've explored a little bit about what we would refer to as a standard cable, and we've picked on PVC, now we can start looking at low fire hazard cables. So based on what we've just learned about PVC, we should be able to answer the next question. So what are low fire hazard cables? And just a clue to the answer to the question, what are they not made of? Well, the answer quite simply is that what we would call a low fire hazard cable is manufactured from materials rather than something standard like PVC. So the outcome is that during a fire, these cables produce low levels of smoke, very little toxic gas, and obviously another key thing is they reduce the spread of the fire. If we think of cables in a building, these provide significant routes for fire to travel from one room to another. So it's important that whilst we're concentrating on reducing smoke and controlling toxic gases, that we're also preventing the fire from spreading from one location to another. So low fire hazard cables are designed to tackle these three issues. As I mentioned during the agenda, we're going to take a look at an institution which obviously quite rightly insists on the use of low fire hazard cables, and London Underground. But there was an event that unfortunately we marked 30 years in November last year that really led to a massive turnaround in what was used in the underground network. So those of you who are listening in probably realise that that event was back in 1987. It was London King's Cross fire. A total of 31 people perished that day, sadly. From what the investigators discovered was actually a fire caused simply by a match, possibly tossed by a passenger. No one knows. But back in the 80s, the escalators on the underground were made of wood. So the match was tossed, obviously fell beneath the escalator. Escalators being made of wood, but also a lot of combustible material down there. But a cable created a fire. The fire initially was the size of a cardboard box, but very quickly, within 5 to 10 minutes, the fire had burnt out of control and had actually been projected up the escalator into the ticket hall. So as I said, 31 people died that day, a lot of them because they're overcome by gas and smoke inhalation. That's why today, obviously, there's very stringent regulations on what could be used on London Underground networks. So given what we've just learned about, why would we opt for a low fire hazard cable in a construction application? Why would we choose it over a standard cable, say PVC? And obviously the answer we've just covered is one of the primary dangers associated with fire is not the flame, not necessarily the flame itself, but obviously the byproduct of smoke and gas. So therefore, it really is best practice and vital that what we're putting in these buildings is not going to contribute to that environment. So that's why we would choose a low fire hazard cable for these types of applications. So next question. How can low fire hazard cables contribute to fire safety? Again, we've covered most of these. The correct obviously is low fire hazard cable, obviously, as we said, ensure lower smoke, no toxic gas, but importantly, they prevent the spread of fire from one location to another. As we've discussed and I mentioned just a moment ago, when we think of cables in a building, obviously it's a significant route for fire to travel from one room to another. So important that what we're putting in doesn't contribute to that situation. So how fast will you get out of a room on fire? Standard cables versus low fire hazard cables. Obviously, the correct answer is compared to standard cables, your escape time is significantly improved by low fire hazard cables being installed. We're going to show you a quick video which will best demonstrate these effects. So what you can see on screen now, at the top, an example of a standard cable, say PVC, versus a low fire hazard cable below. Now, as you can see from the image above, when the fire breaks out, the room quite quickly is filling with thick black smoke and obviously toxic gas. And as you can see, the person at the top is quite quickly overcome by these chemicals, whereas the person at the lower level on the low fire hazard cable section is able to escape due to the reaction of the cable. Now, the example on screen is obviously very straightforward. You can see that the escape is quite near to where the fire is breaking out. But if we just take a moment to think of a more complicated building where escape may not be that easy because you're not near a fire escape, you can see that the standard cable would produce an issue. So as you can see, it would improve evacuation time significantly. Another important question about the quantity of cables in the modern construction. Obviously, if we think of our homes at the moment, all the smart gadgets and equipment that we have in our homes, is that a relevant factor when we consider fire safety? And the simple answer is yes, absolutely. Roughly compared to the 50s, you had around 15 minutes when a fire broke out for fatal conditions to occur. That's compared to about 3 minutes today. Now, to bear in mind that that time span doesn't include that the time you actually discover that your house is on fire. So, by the time you discover it, it may already be too late. So that's why the use of cables in modern design and construction is a significant issue to understand. But now, a kind of a supply question: are low fire hazard cables more expensive than standard cables? And the answer is yes, but they are widely available in the market today. But obviously, as I've mentioned, you do need to consider there is a price difference. These are approximate figures, around 10 or 15% difference. But really, the price gap is negligible when we consider the safety of people in buildings. And the costs and consequences associated with a fire. This is really an awareness question, really. I'm just going to show you some statistics, which hopefully to deliver the message. Centre for Fire Statistics, that's a UK-based organisation, estimates 90% of fire deaths are caused by fires in buildings. That's all fires. 90% are caused by deaths by fires are due to fires in buildings. British Department of Community and Local Government, it's a government agency, estimates that 44% of deaths from a fire are caused by being overcome by gas and smoke. So from that statistic alone, you can see that the importance of controlling that outbreak in a fire is very important. And on a European level, 30,000 victims estimated are claimed every year in Europe from gas and smoke and fires. So given these facts, it is obviously very important that what we're putting into these buildings isn't contributing to that environment. Now, an operational performance question. Do low fire hazard cables carry less current than a standard cable? Important question and one worth asking. The answer to that is actually no. Low fire hazard cables perform equally as well as standardly constructed cables. There are no issues with performance when we compare the two. But what about the complete range? If I'm an installer and I'm working on a building, are there going to be in some of the applications that I'm using where I can't actually use a low fire hazard cable? It's an important question to ask. The answer to that is simply no. You will find that most applications will have a low fire hazard cable. You can see the list there from power cable, data cable, telecom cable, fire alarm cable. For these applications, you'll be able to find a low fire hazard cable that's suitable for the application. An important question. We've covered some of this during the first few slides, but which applications are we talking about that can really benefit from low fire hazard cables? If we cast our mind back to what we've spoken about, we could probably answer this question quite easily. The answer is all applications can really benefit from low fire hazard cables, especially in construction where we consider human and animal life. Some lists of some actions there that are quite obvious. As I say, any applications like this really would benefit from the use of low fire hazard cables. Now, I mentioned at the beginning that when I'm talking about low fire hazard cables, I'm actually talking about more than one type. So now we're going to focus on two different types of low fire hazard cables for two different applications. Now, both these cables or types of cables are characterized by they produce a limited flame spreads, reduce smoke emissions, and virtually no corrosive gases, but they both are designed for two different types of applications. The two classes of cable that I'm referring to are flame retardant and fire resistant cable. Both perform or are suitable for separate applications. A flame retardant cable, as we've already spoken about, will produce low levels of smoke, virtually no toxic gases, and will limit flame spread. But where a fire resistant cables come into play is where you have life safety or firefighting applications, where the cable is required to maintain circuit integrity during a fire, is where you would use a fire resistant cable and not just flame retardant cable. The issue with a flame retardant cable is obviously it won't contribute to dangerous environment, but it will cease to work or power applications whilst the fire is in progress. That's why you need a fire resistant cable for use on that type of application. And as this slide just covers basically what I've been talking about maintaining circuit integrity during a fire. Just some examples of some applications that you're probably already aware of on screen where either life safety or firefighting applications, fire alarm systems, emergency lighting, firefighting lifts. These applications are where it is preferential when required, really, that we should be using a fire resistant cable, such as a BS7846 type cable over, say, a standard BS6724 armored cable for firefighting and life safety applications. Now we move on to some testing regulations and some standards. I'm just going to pick out the relevant ones to what we've just discussed. If we look at the second one down on the list, obviously just to, as you may already be aware, where we see IEC is an international regulations, EN is European, and obviously where you see BS-EN is where the European standards have been adopted into the British standards, and obviously BS alone is a British standard. But if we look at BS-EN 60332, this is actually a series of tests. You have the 60332-1-2, which is what we refer to as a Bunsen burner or a paper basket type test. This is actually where a PVC type cable will actually pass the test. It's a 60-second or 120-second test, dependent on the size of cable, with a Bunsen burner type frame. The test is deemed passed if the cable material self-extinguishes after the fire has been removed. It's really when we look at the next level of the 60332 testing, which is a -3, which is several different tests, which is what we call vertical flame bunched cable test. This is where a low fire hazard cable would pass the test. So it's an important one to look out for there. Another one I want to pick up on is BS6387, which is a test for category F2 fire resistant cables, fire shock and water spray tests. This is actually conducted as 3 separate tests as part of the standard, but it is for fire resistant cables. And the last one I just want to pick up on there is BSEN 50399, which is a test for the CPR. The CPR we're going to just talk about in a little while. So I just wanted to raise your attention to that one before we move on to the next slide. Obviously, this, as I mentioned at the beginning, this training course is going to be made available at the end for you to download and review the information. So, as I mentioned, and I just touched on the last slide about CPR, if we're talking about low fire hazard cables, and it's important that we mention, we talk about the CPR. So, let's kick it off. What is CPR? The answer to that is the CPR is the construction and product regulations. It's a European-wide initiative. The initiative is aimed at standardizing regulation across Europe for materials that are designated as for fixed permanent install in a commercial construction. Now, as I say, it covers multiple criteria and all products for construction. But when we're talking about cables, we're talking about the reaction to fire criteria of cables. Now, CPR itself has been around for a number of years, but when we're talking about fire retardant cables, the regulation came in July 2016. We had a transition year from July 2016 to July 2017 to allow manufacturers to adapt to the new regulation. But from the 1st of July 2017, all manufacturers that were supplying cable into the European Union, which they designated for use in commercial buildings, had to follow the construction product regulation procedures. So what are those procedures? What is the three-stage process for a manufacturer to be CPR compliant? Well, as you can see there, the three steps are there. The first is to obtain third-party testing from a notified body. In the UK, BASEC, as I'm sure we're all aware, British Approval Service for Cables, are approved by the EU to carry out CPR testing on cables. So as the first step for the manufacturer is to send the cable to BASEC for them to test and then obviously approve what we call a Euro class. So basically, just to explain briefly, from now on, fire retardant cables, not fire resistant cables, it's important to mention, they are not, cables designated as fire resistant are not part of the CPR scope yet. It's fire retardant cables that are. So the cable is sent to BASEC, where it is then fire tested. BASEC will then approve a Euro class for the cable, and that is a scale running from A to F. If a cable is an F, it has no resistance to fire whatsoever, and if it's an A, then it has great resistance to fire. But it's obviously about choosing the right category of cable for your application. You wouldn't then just say, oh, that's great, I'll select a category A cable for all my applications because the cost of the cable would be astronomical. So it's about using the right level of fire resistancy for your application. But once the cable has gone to BASEC, they will test and then obviously approve the Euro class. The next step for the manufacturer is to draw up a declaration of performance, or imaginatively called a DOP. Now, if we think of this a little like a quality certificate, where the manufacturer will make this available to whoever requires a copy of it. I say normally this would be available via a download from the manufacturer's website. The declaration of performance must contain the required information such as the manufacturer's name, the Euro class of the product, the location of the factory, description of the product, and obviously the application that it is designed for. So you draw up a declaration of performance. The next one step is to produce a CE marking for the cable, drum, or packaging. In the past, it was normal for a manufacturer to print CE on the sheath of the cable. This is no longer accepted under the CPR. The manufacturer now needs to attach a drum label to the drum or the cable packaging, and the label contains similar information to the DOP. So just as long as a specifier or a contractor, when asked to prove that a cable is CPR compliant, or a manufacturer indeed, if they can produce both the DOP and the CPR label and they are in the correct format, then that will demonstrate the product is CPR compliant. It's important to mention that although the CPR is live and the manufacturers must follow the processes, in the UK at the moment, the UK government is not yet stipulating required Euro classes for certain applications. This is not the case in Europe, but obviously the CPR is really down to the relevant country to decide how it should be used. And for the moment, the UK government is not stipulating Euro classes. It's been left to the industry itself. So the feeling in the UK at the moment is this direction will come from either specifiers or contractors when they obviously design their application. So for the moment in the UK, it's important for the market just to be aware of how to spot that a cable is CPR compliant. So we're just nearly finished. So thank you very much for your attention today. I just wanted to finish up on a few things. A question obviously people like to ask is how do we how do we know that cables are fully approved and tested, and that what we're using is safe? It's obviously a very key concern in the UK today. Really, there's two bodies to focus on when it comes to low fire hazard cables in the UK. Two approval bodies, really, as I've mentioned, BASEC obviously tests fire retardant cable, so it would be advisable to look for a cable when specifying that has been tested and approved by BASEC. Obviously, this can be seen on the sheath, or the manufacturer can produce a certificate to that. But another important one to look out for, especially on fire-resistant cable, is the Loss Prevention Certification Board, which are part of the BRE, and they are testing all products for commercial buildings, so not just cables. So very important for fire-resistant cables, especially, to look that the cable has also been tested by the LPCB. So just to finish off now, just as I say, this course will be made available to you to view and download at your leisure. But I just wanted to touch on the Jargon Buster, which you'll have access to at the end, especially the first three, because this is commonly used terminology in the UK. Low smoke, zero halogen. So if you look at the first and the third one, so LSZH, LS0H, they both mean the same thing, just a zero is used instead of a Z to designate a low smoke, zero halogen cable. The second one is one to just be a little bit careful of, which is used a lot in the UK, is LSF, low smoke and fume. Low smoke and fume can actually refer to a PVC type cable with a reduced amount of halogens in the manufacturing process, which indeed does produce lower levels of smoke and toxic fume, but won't perform as well as a proper low smoke, zero halogen cable in a fire. So just for a quick comparison, roughly around 18 to 28% of the smoke given off by an LSF cable would still be toxic when we compare to roughly about 0.5% on the low smoke, zero halogen cable. So just one to be very aware of when you're requesting cable types. But as I say, there's 2 pages of handy Jargon Buster here for you to have a look at your leisure, just breaking down some of the abbreviations that are used in the UK market. Well, thank you again very much for joining us on this sunny Friday lunchtime. I will now ask my colleague Gerhard Novak to join me, and we'll start to answer some of the questions that have been posed while I've been talking, and Gerhard will help me answer some of those questions now.
Yes. So a very good afternoon, ladies and gentlemen. I don't know if we have any ladies in it, but in case I try to be polite. And I can look at the first question. Can you clarify the difference between flame retardant and fire resistant? Fire resistant is when you have a cable which has to work during a fire. So it is not important, or let's say it is not so important if the cable is transporting the fire from A to B, but it is important that the fire is working. Where do we need such a cable? Think about 3 major applications. First is fire alarm. You would like to press a button and you would like to be sure that the fire alarm is actually working. Also in the next room where the cable goes through is already burning. The next thing is emergency lighting. Even if the cable has low smoke production, it may be that the main supply breaks down because the cables for the main supply are probably not fire retardant or flame retardant or fire resistant cables. So you would be in the dark. So this cable helps you to find your way out, because you have emergency lighting. And the third group is everything which has to work during firefighting. Means you are already out, but now the fire brigade is in the building and they need also something working by electricity. What is that? Things like water pressure pumps, automatic smoke valves, or similar things which have to work during firefighting. So these are the main groups. And if we speak about flame retardant, then the main thing is that the cable doesn't transport the fire from one location into another. And the the cable on its own is also self-extinguishing. And this is important, that if you have a fire somewhere in a building, it stays local and it doesn't go from one place in the building to another one, using the cable itself as a kind of a means to transport it. Then the next question, is there any plan for this to become a legal requirement in domestic dwellings? This cannot be said at the moment. We have the only thing, the only paper where you see that fire retardant or low smoke zero halogen cables have to be used is the wiring regulations. In the current edition of the wiring regulations, you will see that in escape routes you have to use cables according to IEC 332-3 category C. This is, of course, a standard before the CPR was in force. But also the next edition, I can already tell you, will not have anything said about the CPR. So it may be that there will be an amendment in the future, but at the moment we cannot say if there will be a legal requirement in domestic dwellings. I don't think it will happen in the next years. But as we had some bad fire in the near past, it may be that this also will reflect on the regulations, but this cannot be said at the moment. Next question. If cables are no longer CE marked, how do we verify whether or not an approved cable has been used when surveying existing installations past July 2017? The CE marking is normally, or let's say part of it, is a self-declaration. So I would rather look for a different marking, which is a marking from BASEC, for instance, to be sure that you have the right quality. Also, as Dan before has mentioned during his presentation, you have the CE marking on the documentation. It is really important to keep the documentation and to get the documentation from whoever you buy the cable, because if in the later future there may be any claims, it may become necessary to use these cables, and if there are any claims, then you can always from the documentation say that you have used the right product, which was according to the specifications of the day you have made these installations. Okay, most cables installed in buildings these days are low smoke zero halogen that goes into PVC trunking or PVC conduit. When will containment manufacturers, designers catch up? Here I cannot give you a correct answer because I am, as is clear, I am from the cable industry, so I know very well the situations about cable, or I think I know it very well. I do not know the situation about PVC conduits and PVC containments. In any case, if you want to be sure that you do the right thing, then I would not use PVC products. I would rather go for low smoke zero halogen products or metal products to fix your cables, because the best cable will not work if it falls down from where it has been installed. So these are all questions I could see here. Of course, if you have any questions later, you can always write it and we can answer it in a written form later. So we have another one. Are fire-rated cables required to go within fire-rated compartment trunking for life safety diverse routes? If you have a fire-rated compartment trunking, normally you do not need fire-rated cables. The compartment should be good enough to save the cable for a given time, so you don't have to fulfill that. I think the new BS 7671 shall specify not to use the PVC in risk areas. I have to say I have seen it and I have read parts of it, but I cannot confirm that at the moment. The 18th edition will be published, I think, in the second half of this year, and I cannot confirm that at the moment. Heat transfer to the cables. If you have fire-rated compartment trunking, then normally you have some kind of mechanism in it which is keeping also the heat out for a certain time, which means things like foaming agents which make a kind of a foam around this compartment or similar methods. So, of course, the cable will not work forever, but I have to say no cable will work forever in a fire. Even a fire-resistant cable will only work for a certain time. The higher the class, the longer it will work. For instance, the fire-resistant cable for fire alarm and emergency lighting will work for 30 minutes. But it is expected that after 30 minutes, the building should be evacuated. Is it true under BS 999 that low smoke zero halogen cables have a higher fire load rating in joules than PVC, or have I been misinformed? No, this is true. Or let's say it can be true. It depends on the cable design. There are PVC cables which are extremely good in fire performance, which means they will not burn. They will not transport the fire anywhere else, but you still have the issue of the corrosive combustion gases of PVC. So this problem is always there, even if you have a very good cable. And if you have low smoke zero halogen cables, they are all polymer based, so there is something in this material which can burn, but these substances are not producing any poisonous or corrosive gases when they are burning. So from the joule load, it may happen that the low smoke zero halogen cable is higher than PVC. That's correct. A case where PVC is preferable to low smoke zero halogen, I would not see, for two reasons. Even if the joule load is lower, the big problem we have learned before in this presentation is the evacuation. So you have to get your people out of the building, and this is the absolute first priority. The second problem, which is also important, is not life-threatening, but is important. The corrosivity of the combustion gases of PVC is such that all metal parts which are in contact with this gas will corrode. And this means that if you have any electronic circuits or machinery which has bare metal surfaces, it will corrode and you have to replace it. This goes even further. If not treated in the right way in the short time after the fire, even the armoring inside the concrete of the building itself can corrode. And there have been cases known that buildings have to be put down because the armoring iron in the building has corroded because of PVC fires. So for this reason, I would say PVC is not preferable to low smoke zero halogen products. First of all, because of the risk of to human life, and second, also the destruction of all metallic parts inside the building. Are there any documents easily available that identify this? And now I have to say, identify what? That PVC has a higher fire load. Okay, I see. Yes. I'm not sure if I know any documents here, but I know some documents from other European countries where this is documented. But as I said, the higher fire load is not the problem. The problem are the corrosive gases during combustion. You're welcome.
All right, guys, I think we'll conclude it there. Thank you all very much for your questions. Much appreciated. And again, Gerhard and myself really appreciate your time this afternoon. Obviously, my contact details are on screen there. So if you've got any additional questions that we didn't get time to answer today, then please do give me a call or drop me an email, and we'll endeavour to get you the answers that you need. But again, thank you very much for your time, and have a great Friday afternoon and weekend.